Hello and welcome to the Managing Lightweight Kubernetes on ARM64 Edge Cluster screencast. This screencast demonstrates the provisioning and the management of lightweight Kubernetes cluster on the ARM64 based host using the CAPI Appliance. It highlights the following key capabilities: ARM64 architecture support and Ampere certification. OpenNebula is fully compatible with ARM64 and has been officially certified on Ampere Altra servers, ensuring high performance and energy efficient operations across the cloud and edge environments. CAPI Appliance to deploy and manage Kubernetes cluster. The CAPI Appliance provides an out-of-the-box solution for managing Kubernetes cluster using OpenNebula. Rancher integration to simplify the deployment and management. Rancher's intuitive web interface can be used to simplify the deployment and lifecycle management of OpenNebula CAPI ARC2 clusters. The whole OpenNebula environment, including front-end servers and hosts, is managed and configured automatically in the form of a code using the one deploy. After the successful deployment of the OpenNebula environment, the CAPI appliance must be imported from the OpenNebula public marketplace. The appliance is supposed to be deployed to a host, keeping in mind that CAPI appliance must be able to communicate with the OpenNebula frontend and virtual machines that are going to get deployed later. When appliance has been deployed and the Rancher web UI is reachable, we can start provisioning the cluster. The job can be split into two parts. Firstly, CAPI Appliance is going to deploy the necessary number of virtual machines via the OpenNebula API interface. Secondly, CAPI Appliance is going to establish the connection to the deployed virtual machines and will configure it to join the respective Kubernetes cluster. Once the Kubernetes cluster is running, you can start using it to deploy applications. If needed, CAPI Appliance is going to take care of the Kubernetes cluster upgrade, scaling, and maintenance. While CAPI Appliance is managing the Kubernetes cluster, OpenNebula takes care of the virtual machine resource allocation, backup, migration, and monitoring. As a first step, we must instantiate the CAPI appliance. Same as with any other virtual machine template, you can define the allocated resources. Under the user input, you can adjust the appliance-specific settings. As most of the things are pre-configured already, the only adjustment we must make is to join the network. It's going to take some time while an appliance is bootstrapping. CAPI appliance itself is based on the Kubernetes, and to observe the bootstrapping process, you can connect to the appliance via the secure shell and run kubectl command to list all pods. Once an appliance is fully deployed and running, access the Rancher web interface using the browser. Proceed by using the default credentials to access the management interface. The deployment of a Kubernetes cluster can be started using Helm charts. Under the Rancher Apps charts, select the Cap1 RKE2 chart. We are supposed to run the customized settings, and that's why the checkbox Customize Helm option before install must be checked. Time to substitute the original YAML file with the custom YAML that's going to describe the Kubernetes cluster settings along with the OpenNebula specific image and template configurations. Press Install button to finalize the deployment. It's going to take some time to provision the cluster. As a part of the cluster, you are going to have the virtual router component, control plane node, and the worker node. By going back to OpenNebula Sunstone interface, you can observe the virtual machine's deployment and their current state. Now we can confirm that the cluster is up and running, however, not yet managed by the Rancher. You must import the cluster into the Rancher. To achieve that, we must run a few commands. Firstly, we must get the custom kube config from the deployed cluster. Afterwards, we are going to use the dedicated import command. Please note that we are running the curl command with the insecure flag because of the self-signed certificate. After the execution of the command, the state value of a cluster firstly will be changed to waiting and then to active. Once the state is shown as active, the cluster is ready to be fully managed by Rancher. Once the cluster is managed by Rancher, we can start performing actions with the cluster. For starters, let's scale the number of worker nodes from 1 to 2. For that, we must navigate to the cluster management, CAPI, machine deployment, and edit the YAML file. Look for the replicas parameter and set it to 2. After clicking Save, the scaling is going to take off. In the OpenNebula Soundstone interface, we already can find the newly created virtual machine. We also may execute the kubectl get nodes to list the available nodes and see where the newly created node has joined the cluster already. Let's proceed with the upgrade of a cluster. Currently, we are running the outdated version of Kubernetes and we are willing to run the latest available. For that, simply navigate to Cluster Management and locate the cluster you want to upgrade. In our case, the candidate for an upgrade is the demo CAPI cluster. From the three-dot option menu, select the Edit config. Under the Basic section, from the drop-down menu, select the desired version. The upgrade has been initiated and is going to take some time. Once the process is finished, we can be sure that our cluster is running on the latest version. This screencast is produced in the scope of One Next Gen project. Thank you for watching and see you in the next screencast.